Okay, so types of rational functions. In the last lessons, we graphed where the degree of the numerator was less than the degree of the denominator, and we only had linear parts. Right? We had constants, we had an x or an x plus or minus something. So now we're going to go to the next style of rational function. And now the degree of the numerator is the same as the degree of the denominator. Right? So now not just going to be a constant in the numerator, there'll be an x term. It's linear, so we're still just going to have x to the first power. But now we're going to have an x in the numerator and an x in the denominator. All right, so our second type of rational function still creates a hyperbola, still creates that same shape that we're used to with the rational functions. We're going to have y equals ax plus b over cx plus d. Has vertical asymptotes when cx plus d equals 0. So we're going to set our denominator to equal to 0 and solve, right, because our denominator can't be equal to 0. And it has a horizontal asymptote at the, what's called a over c. It's the ratio of the coefficients of x. If this isn't in your notes, add that to your notes, which you may have done yesterday. All right, so here's our steps. All right, so I don't know why that part's blue, but maybe it looks pretty that way. So we have vertical asymptotes, or values which make the denominator equal to 0. You're going to set each factor of the denominator equal to 0. Right now, we're going to have one factor in the denominator. So with that factor, you're going to set equal to 0. We're going to have horizontal asymptote. I don't know why it says totes. It really should just say asymptote. There is going to be only one. We can have two. But these ones won't have 2. Let's get rid of the s. There we go. Y equals a over c, and that would be the ratio of the coefficients. It could also be, and I think it's already in your notes, make this a little bit, see if I can extend the screen a little bit. No? Well, hopefully you can see the bottom there. There we go. I think you can see it now a little bit better. It could also be a over c plus k. So if we have a constant added to the whole thing, so we have an x in the numerator, an x in the denominator, and then a constant added to the whole function, the horizontal asymptote will be this ratio plus that constant. And so we might see one or two like that. We'll plot 2 or 3 points on either side of a vertical asymptote. Determine domain. This is true all the time. Values that make the denominator of a fraction equal to 0 are not included in the domain of a rational function. So the domain is going to be all real numbers except the vertical asymptote. That's going to be true all the time. If a rational function does not cross the horizontal asymptote, the range is generally all y values except the value of the horizontal asymptote. On these particular rational functions, it will be the range will be all real numbers except the horizontal asymptote. We'll see some where they're different when we have some nonlinear parts, but right now it's going to be all real numbers but not the horizontal asymptote. Okay? And of course you can always just use the graph to help you. Okay? All right, so let's graph some. All right, so here's our first one. All right, so we want to find the vertical asymptote. Let me move those things up. How do we find the vertical asymptote? Purple 4.
Negative 3.
No. What do I do to find it?
The equation.
What's that?
In the equation?
Yeah, so what do I do to find it? So what does it say? It's like the very first step in your notes. Step number 1.
Oh, make the denominator equal to 0.
Yeah, make the denominator equal to 0. So we have 3x plus 3 equals 0. And the writing should come along anytime. There it is. Subtract 3 from both sides. Right? So 3x equals negative 3. And if we divide by 3, we can see that x is equal to negative 1. That's our vertical asymptote. If we plug negative 1 in, right, that would make the denominator 0. So we will graph that. There we go. So now we need the horizontal asymptote. Anyone going to give a try to what the horizontal asymptote is? Remember it says the ratio of the coefficients, so it would be... Is correct. Who said that? Good job, Devin. That was 1/3. So y equals 1/3 is correct, right? So there's a 1 there, right, in front of the x. So it'd be 1/3. Just be the coefficients of the x values. So we'll just have to graph this really small. Is this one in your notes?
Yeah.
Okay. You'll probably do better than me. Ignore the little glitch on the left side of the board where it dips underneath the, maybe I can drag some horizontal asymptote in over here. Because it shouldn't dip below the board, below the x-axis, but I can't seem to do anything about it. There we go. That looks a little better. All right, we'll plug in some values. I do try to give myself nice values to graph whenever possible. Sometimes when there's an x term, when there's stuff in the numerator and stuff in the denominator, it starts to get hard to think of nice terms. So when it gets harder to think in nice terms, I just plug in some values on either side. Right? But if I can make this equal to 1, that's usually a good thing. Right? So if the denominator can be 1 or -1, I'm going to get an integer value. Right? Maybe 2 or -2 would work out nicely as well. We could plug, so we'll plug in some on either side. We'll plug in 3 and hope for the best. -2, -3, and -4. And then on the other side, we'll plug in 0, 1, and 2. And see what happens. All right, and if we think of something better than the ones we got here, then we can do that. All right, so we have -2 minus 2 over -2 times 3 plus 3. All right, so that's going to give us -4 in the numerator. And in the denominator, -3. So 4/3. Well, that's not too bad. Then we have -3, -3 minus 2 over -3. I reversed the -2 and the 3, but it didn't make a difference. 3 times -3. I'm going to have to make these a little farther apart. I can already see I'm running out of space. 3 times -3 plus 3. That's going to be -5 in the numerator. -6 plus 3 would be, -9 plus 3 would be -6. So that's going to be 5, 6. So none of these are integers. It gets a little harder to come up with integers. So now we'll take 0. And if we plug in 0, we can see the x's would be gone, and that would be 2/3. -2/3. Right? That'd just be -2/3. And then we'll plug in 1. And then we have 1 minus 2 over 3 times 1 plus 3 is going to be -1/6. And we'll take 2. Oh, I think I said I was going to take -4 too. We'll plug in -4 at the end. We have, here's a nice one. 2 minus 2. 3 times 2 plus 3, that's just 0. That one's nice. All right, we'll plug in, we forgot -4. So we wanted 3 on the other side. Let's plug in -4. So -4 minus 2 divided by 3 times -4 plus 3. So that's going to be -6. And then that would be -12 plus 3. So that's going to be -9. So that'll be 2/3. All right, so we'll graph those 6 points. We got one integer out of it. We got a 0. All right, so we have -2, 4/3, so 1 1/3 there. 5, 6 is a little less than 1, and that's for -3. And then 2/3 is even a little less. So kind of small values there. On the other side, we have 1, -1/6. So that's right about here. Almost, let's see. Oh, I forgot 0. 0, -2/3. All right, that's a little bit more. That's about there. And then we got 2, 0. And then -4 was, we got -4 in there. Those are 3 points. All right, so all pretty small values, pretty close to hugging that. Oops. And there goes my line below the asymptote. So in reality, it's not going to go below the asymptote. Maybe I just didn't draw it over here. It's going to be above the asymptote. It's not going to cross. We'll just end that graph there. And then on the other side, we will not cross that. We cannot cross the vertical asymptote. It will not cross the horizontal, but it will get close. All right, let's do domain and range, and then we'll do end behavior. All right, how about the domain? Yellow, no yellow 5. No orange 5, right? Orange 2. What's the domain? Yep. Yep. So negative infinity, negative 1, negative 1 to infinity. How about the range? Yellow 2.
Negative infinity.
Yep, negative infinity to 1/3. 1/3 to infinity. There we go. Let's do the end behavior real quick. I'll write in purple. All right, so f of x goes to, of course, it's going to go to the horizontal asymptote. So approaches 1/3 as x approaches negative infinity. And then as we get close to the vertical asymptote on the negative side, the graph is going to go to infinity as x approaches negative 1 from the negative side. And it splits, it approaches negative infinity as x approaches negative 1 from the positive side. And of course, as it goes to infinity, again, it's going to head toward the horizontal asymptote, so it's going to approach 1/3 as x approaches infinity. So there's the end behaviors as it goes to the vertical asymptote and as it goes to the, as it gets larger and larger and smaller. Any questions on anything? Any questions on asymptotes, end behavior, graphing, anything at all? We'll do another one. I think there's maybe like 4 on here. How many on your notes? 4, it switches. One more?
Yeah, the next thing is rational functions and their graphs. Was that this one?
And people are watching this. You can be taking notes while they are too. And if people watching this, if you have questions, well, there'll be a little box where you can ask me your questions on the Nearpod. All right, so here's the next one. Is this one in the notes? Nope. Saw asterisk, that's what I wondered. All right, so vertical asymptote. Anybody at orange? It would be 3. So x equals 3, because we said x minus 3 equal to 0. And you add 3 to both sides, of course, x is 3. The horizontal asymptote. Anybody at purple? 1 is correct. Right? So since we don't see a coefficient, it's technically 1. 1 over 1 is 1. So y equals 1. Oops, I'm going to graph that in red. Trying to keep the 2 asymptotes different colors. Color coding here. So we'll graph both of those. Right? So it's the horizontal asymptote. There it goes. So actually, the glitch isn't too bad on this one. And then x equals 3 is the vertical. And then we'll choose values on either side of 3. So, and actually it's pretty easy to make that be equal to either negative 1 or make it equal to positive 1. So we definitely want to choose 2 and 4 because that's going to give us integers. But we'll just plug in some values. Maybe I'll do green. All right, so x, y, let's take 2. Let's take 0, 1, and 2, the three values next to it. 0, 1, and 2. If we plug in 0, of course the x's would be gone, and that would be 1/3. 1 would be 1 minus 1 over 1 minus 3. Doesn't really matter what number's in the denominator, 0 is in the numerator, so that's just 0. That was a nice choice. Wait, got an integer there. And 2, we'd have 2 minus 1 over 2 minus 3. That's going to be 1 in the numerator and negative 1 in the denominator. Come on. It's thinking. Where's the rest of my numbers? There they are. So that's just negative 1. We got two integers. All right, and so now on the other side, let's use 4. If we plug in 4, that one's going to be nice. We'll have 4 minus 1 over 4 minus 3. So that's going to be 3 over 1. That's 3. Got 3 integers. And then we'll take 5. 5 minus 1 over 5 minus 3. That's going to be 4. And then 5 minus 3 is 2. 2. We're looking out here. They're all integers. And the last one, we'll take 6. So see if I can squeeze it in here. 6 minus 1 over 6 minus 3. Another good choice. No, well, not as pretty. Our luck ran out on the integers. So we have 5/3. All right, so those will be our values. Hopefully you can see them, both in class and watching this. All right, so we have 0, 1/3. All right, so right there. And then 1, 0. Oops, what did I do? 1, 0, there we go. Looking for where 1, 0 is. 2, negative 1. All right, that's all we have on that side. And then we have, boy, this goes downhill, doesn't it? 4, 3. 5, 2. And 6, 5/3. So 1 and 2/3. I'm going a little slowly there. All right, so can't cross the vertical, won't cross the horizontal. There we go on that side. Same thing over here. Won't cross the horizontal, can't cross the vertical. Notice these shapes are very much the same as the other ones, right? So as long as there's linear in there, even when they have the same degree, shape doesn't really change much. Might grow a little faster or something like that, but it doesn't really change the shape very much, the overall shape. All right, but it still changes how fast it grows, what the values are. So when we're doing these, make sure you find values on either side. 3 is good. 3 on the right of the vertical asymptote, 3 on the left of the vertical asymptote. That'd be fine. Right? Don't worry about positive and negative, just where it is relative to the vertical asymptote. And then domain, purple 1. Huh?
3 positive infinity.
Yeah, negative infinity to 3, 3 to positive infinity. Ooh, that looks like a B. And then how about the range? Purple 2.
The range is negative infinity to 1.
Yep.
And 1 to infinity.
There we go. And let's just do the end behavior. All right, so f of x approaches the horizontal asymptote, which is 1, as x approaches negative infinity. It's this time it's approaching negative infinity as we approach that vertical asymptote as x approaches 3. Oops, sorry. X equals 3. X approaches 3. X never equals 3. Oops, there goes my purple. And then f of x approaches positive infinity. Oh, and this was 3 from the negative side. F of x approaches positive infinity as x approaches 3 from the positive side. And then, of course, as we approach positive infinity, it's going to approach the horizontal asymptote again. All right, any questions on that one? Doing good. Got 2 done. All right. No, you don't need me to wait for you, right? Because this one wasn't in the notes? Okay. So not in the notes. Just got to enjoy that one. And now we're on this one. This one in the notes?
No.
Nope.
No.
How about that one?
Yes.
Yeah, okay. All right, so vertical asymptote. I'm going to move these things so I have a little bit more
It just
space.
changed.
What's that?
It just changed.
Oh, I know. This is the other one.
Oh, we're doing this one?
Yeah, that was first. I was just curious which ones were in your notes. All right, so let's do the vertical asymptote. Blue 2.
-1.
X equals negative 1. So make sure it's x equals, right, because it's a vertical line. The horizontal asymptote. These are all the people I'm not being called. Huh? Anybody have blue? Sorry, today. What's the horizontal asymptote? Today? What's the horizontal asymptote?
Why again?
Because it's blue. Because Shelby abandoned you.
Yeah. Is it just 1?
No. It's the ratio of the coefficients. Want to help her out? Orange 1. What is it?
Is it 2?
No. Um. Anyone at yellow?
4.
Y equals 4 is correct. Right? So notice it's the ratio of these coefficients. This one's 1. Ratio of the coefficients. That gives you the horizontal asymptote. So let's graph those two. All right, y equals 4. Way up there. And then x equals negative 1. Over there. We'll plug in values on either side. Definitely want to use 0. And that would be a good one to use because that'll at least give us 1 in the denominator there. Negative 2 would be another good one to use. So we'll use negative 2, negative 3, and negative 4. Kind of just go in order. Usually those end up being the better values, the ones closer to the asymptote anyway. So we have 4 times negative 4 plus 2, and then negative 4 plus 1. That's going to be negative 16. That's negative 14 over negative 3, so that's 14 thirds. That's okay. That's just 4 2/3. And then 4 times negative 3 plus 2. And then negative 3 plus 1. So that'll be negative 12 plus 2. So that's negative 10 divided by negative 2. That's 5. That's a nice one. And then 4 times negative 2 plus 2. So that's going to be negative 8 plus 2. That'll be negative 6 over negative 2 plus 1. That's, oops, you can see the 2 there. That's just going to be negative 6 divided by negative 1. That's 6. Got 2 integers here. I'm doing well. And then 0. That's just going to be 2. Right? Only thing that's going to be left is the 2 over 1. And then 1 would be 4 times 1 plus 2. That's going to be 6. What am I saying? 6. And then 1 plus 1, that'd be 6 divided by 2. That's 3. I got nice values here. And then finally, let's use 2. And that would be 4 times 2 plus 2 is 10. And then 2 plus 1 is 3, so 10 thirds. Not bad. Not bad values. All right, so we'll graph those. Negative 4, negative, or 14 thirds. So that's going to be right. So it's going to be 4 and 2/3 right there. And then we got negative 3, 5. And negative 2, 6. On the other side, 0, 2. 1, 3. And 2, 10 thirds. So 3 and a third. All right, so it cannot cross, it will not cross, cannot cross vertical asymptote, will not cross horizontal asymptote. There we go, and a little glitch there goes along with the asymptote. All right, so there's our graph there. And let's do domain and range. I'll move this over a little bit. Doing domain orange 4.
That would be negative infinity to negative 1. Negative 1 to infinity.
Huh? And the range, yellow 4. What's the range, Jeff? Where's that's the vertical asymptote. That's on the x's. 4, good. Uh-huh. And then?
Negative 4 to infinity.
No. The only place it stops, right, is at the at that horizontal asymptote. What's the last part? What's the last part, class?
4 to infinity.
4 to infinity. Phone away. All right, and then the end behavior. All right, so we have the function approaches 4 as x approaches negative infinity. The function approaches positive infinity as x approaches the vertical asymptote, negative 1. And that's from the negative side. Keep forgetting to put that in there. And then the function approaches negative infinity as it approaches that vertical asymptote from the positive side. And then as it goes to infinity, it's going to approach the horizontal asymptote. All right? And there we go. That one's done. We got time to do the next one. All right. Any questions? All right, so this one's in your notes. Let's do this one. So this one now has something added in. Vertical asymptote. And we're back to the beginning. No, I had them red in there. Anyone at purple? Vertical asymptote.
5.
No. What do we do to find the vertical asymptote?
Make the denominator equal to 0.
Right. So if we have 2x minus 1 equals 0, and we add 1 to both sides, we'll have 2x equals 1, and then divide by 2, x is 1/2. All right, and so we'll graph that. See how I do with 1/2. Well, except for on the left-hand side of the board, not too bad. Maybe we'll. There. Add some asymptote in. All right, and then the horizontal asymptote. I don't want to call it the same person when I have other sticks. Yellow 4. Horizontal asymptote. That's part of it. And then plus.
5.
Plus 5, yes. All right, so it's the ratio of these coefficients, what it would be normally. But then we have this plus 5. So we're just shifting the whole thing up another 5. So it's going to be y equals 3. So we'll graph that. And whoops. Anyone notice that I accidentally, and that was recorded too. Hopefully all of you watching were cringing when I made a horizontal line when I was supposed to make a vertical line. There we go, 1/2. Y equals 3 goes here. Oh, I tried to accommodate for the glitch. Almost. Got it on the one side. There's some more horizontal asymptote. There we go. All right, so now we'll plug in values. I'm not going to even try to think of anything that would be an integer. We'll just plug them in on the two sides. So we'll use 1, 2, and 3, and 0, -1, and -2. All right, so -2's first. -4 times -2 plus 3 divided by 2 times -2 minus 1. It's going to give us -8 plus 3, that's -5. And then -4 minus 1 is -5. Hey, how about that? It's 1. And then -1 would be -4 times -1 over, plus 3. And then 2 times -1 minus 1, and then plus 5. Uh-oh, I forgot the plus 5, didn't I? On this last one. Whoops. Not 1. Plus 5. Totally left the plus 5 off. So that's going to be 6, actually. All right, so this is going to be 4 plus 3. It's going to be 7. So we'll have 7 over -3. And then 5 would be 15 thirds. So 22 thirds. That one's not as pretty. 0. All right, so if it's 0, we're going to have a -3, right, because the x's are gone. -3 plus 5. So that's 2. I got 2 integers. And then we've got on the other side 1. So that would be -4 times 1 plus 3 over 2 times 1 minus 1. So that's going to be -4 plus 3 is -1. Oops, and then plus 5. Well, I had 5 to the whole thing. And then 2 minus 1 is 1. So we got a -1 plus 5 is 4. There's another integer. And then 2, -4 times 2 plus 3. We'll just add the 5 in at the end. And then 2 times 2 minus 1 is going to be -8 plus 3. So 5, or -5. And then 4 minus 1 is 3. So -5 thirds plus 15 thirds is going to be 10 thirds as soon as it comes up. There we go. Equals 10 thirds. And then, let's see, we said we're going to use 3. So -4 times 3 plus 3 over 2 times 3 minus 1. I don't think this is going to be an integer. So -12 plus 3 is going to be -8. Or -9. -9. And then 6 minus 1 is 5. So -9 fifths plus 25 fifths is going to be 16 fifths. Oh, we got some integers out of that. So we'll graph those points. Oops, my cord's caught. We have -2, 6. -1, 22 thirds is 7 1/3. And then 0 was 2. Oh, that doesn't seem to make too much sense now, does it? Did we put anything at the wrong? Gee, I don't remember the graph looking like that. Something seems wrong with one of these points. One of these points just doesn't belong. Yeah.
-2, what's it say after the whole problem? What it says
Plus a 5. I had to throw in a plus a 5.
No, before the plus 5. What does that say?
What equals?
Yeah.
-5 over 5? Is that a mistake?
5.
I don't know. -8 plus 3
-5.
would be -5.
It's not -8 though. It's 8 because it's negative.
Oh, it's +8. Oh, thank you. Thank you. Thank you.
So it'd be 11 over 9.
These are wrong. Whoop. There goes our integers. These two are probably both wrong. Thank you. It's good to have another set of eyes. Yeah, I don't know how I got negative. So 8 plus 3 would be 11. And then 11 over -5. So -11 fifths plus 25 fifths is going to be, so that should be the less, 1/5 less than 3. And should be right over here. So it should be underneath. So it should be right about there. So the 2 is right. I didn't think I could mess that one up. And then, oh, but that's for -2. There we go. All right, so let's try that again. +4 plus 3 is going to be 7. And then over -3. And then 15/3. So that's going to be 8/3. So right in between, 2 1/3. So much for our integers, but we got 1. And then we got 2. 1 4. And 2 10/3. So that's 3 1/3. And then 3 1/5. So kind of small. All right, so won't cross the horizontal, can't cross the vertical. Same thing over here. There we go. There's our graph. How about the domain? Anyone at orange? Domain orange? Yep. Yep, you just got to take out that vertical asymptote. And then the range, and you want it yellow. Uh-huh. No, that's the domain. No. 3, there you go. Take out the horizontal asymptote. And then 3 to infinity. All right, let's add the end behavior, and then we'll do and I'll stop this tape for the closing. Uh-oh, I'm caught. Okay, end behavior. So f of x approaches 3 as x approaches -infinity. It's going to approach -infinity. Oops, -infinity. As x approaches 1/2 from the negative side, it'll approach +infinity as x approaches 1/2 from the positive side, and then as x approaches +infinity, our function's approaching 3 again, the horizontal asymptote. And there's our end behaviors, and then I'm going to end this tape, and the rest of the class is going to do their closings. Bye for now.